All right, I think we're ready to begin. Can someone give me a test? Hello? Oh, that didn't work. Why didn't it work? Uh, okay, it's working now. Yay. All right, we can start. Good morning, afternoon, evening, everyone. The first thing on the list is testing, as always. So let's go over that with Dimitri. Dimitri, what are your updates for testing?
So fortunately, I've looked in the test repository, find out that Yoichi actually added some tests for the bitwise shift already. So I ask everybody to check whether it's working on your clients. And I personally think that it's not enough to just write tests for this new opcodes manually. Because last year when Casey did this fast testing, he discovered a lot of new bugs just by running the fast operation and fast program of the arguments that this functions EVM opcodes receive. You're able to find more bugs than you could possibly write manually. So I suggest do that with the new opcodes this time also. Create2 opcode is about to be merged to CPP Ethereum, and I will be ready to start compiling some tests on it. And external code hash seems to be pretty easy to implement. And yeah, what else do we need? What kind of
We're
PIP
we're
need?
considering 1087 for net gas metering for S-Store. We're going to talk about that in a second.
Is it changing the gas price for a store? You mean?
No, it's a little bit different if I understand correctly. Nick, am I right there?
Okay,
Yeah,
I'll have to look at it more.
it's a bit more substantial than just changing the gas price. But should I go into details now? Or?
You can just, if you have like a summary for Dimitri.
Sure. So the basic idea is that when you do multiple writes to a single storage element, we are overcharging for gas because we charge multiple disk writes worth of gas. So this proposes to change how gas is metered. So if you write, say, 5 times to the same slot, you only in the net get charged for one write. That's a bit of overview.
So yeah, it's a little bit different than just raising the gas price, Dimitri, and we'll talk a little bit more about how Geth
Mm.
implemented that in a moment. Um,
Yeah, this change will at least require to regenerate all of the tests. Because
Yes.
current tests using store rights to store the actual value for more than just testing the store opcode. Every opcode that I test, I use store operator to put something into the state and see whether the opcode worked correctly or not. So I think it affects all of the tests.
Probably, though not if you only write once, but most likely you have to regenerate the bulk
Yeah.
of the tests.
And I suggest we also implement blockchain test without proof of work.
so what would that mean for everybody?
Just disabling proof of work and
Oh, in the
difficulty check
clients. Okay.
the blockchain tests if the specific flag is set. Because no need to waste time on generating the difficulty for those tests.
Okay, that makes sense to me. Um, so let's see. Is that all the testing updates, Dimitri?
So I can
Um,
add on regarding fast testing.
Great.
We'll be starting to restart fast testing again. We need to do some updates both to the libfuzzer based testing and to the testdef / EVM lab based random generator fuzzing to make sure that we get the new opcodes and everything. And yeah, so and that part requires that. I mean, it's differential testing, so it requires that it's implemented at least in 2 clients and preferably Geth and parity and do differential testing between those. Yeah, so it's a bit of work usually to configure it correctly so that they're enabled and you have the right genesis and stuff. But I'm hoping that we can get started with the fast testing quite soon after clients merge their PRs. their features.
Okay, wonderful.
I also have a small test update. Just wanted to say that Guido started to fuzz Ethereum J, which is just great. So yeah, that's it.
Awesome. That sounds good. Okay. We'll run through client updates, and then before we get to research updates, what we'll do is we'll talk a little bit about the 1087 and whether or not it's going to go into Constantinople before we go into other things, because Peter has to leave a little early. So for client updates, let's start with Parity. I think that's Frederick or Afri.
Yeah, that's me, I guess, or both. Yeah, so released Parity Ethereum 2.0 last week. This finally concludes what we have been preparing for a while, to have a pure blockchain client for EVM and WASM VM based chains. We stripped out all installers, all wallet user interface, and so on. Yeah, and that's basically where we are now with our 2.0 release. And yeah, we slightly rebranded the client. It's called Parity Ethereum now, just to distinguish it from other software we are building.
Oh, congrats on the new client release.
Thank you.
So, and as far as Constantinople EIPs, is there an update on any implementations of that?
Sorry. We implemented, let me quickly check, we implemented 1.4.5, bitwise shifting, and just as of today, we also have a pull request for 10.52 Xcode hash opcode. That's the Parity status.
Okay, great, thank you.
I don't know, if Fred, do you want to add something?
No, not really.
Okay.
All right, thanks, Parity. Geth, I think that'd be Peter.
Hey all. So as for the Geth, so the bit shifts have been merged on master for a few months now. Martin did those a while back. And last week and this week, we also had implemented the Xcode hash, EIP, and Skinny Create. These have all been merged to master. And we've also implemented Nick's net storage metering PR, which has not yet been merged to master. Nick reviewed it. I think it's a simple enough PR, but I'm kind of holding out with merging it until it's actually decided whether we're going to ship it or not, because I don't want to go back and try to extract it out if we decide against. But essentially, these 4 EIPs are mostly done. Of course, testing pending. And as for the 220, the block hash EIP, it would be nice to figure out whether we go with 210. So it would be nice to figure out whether we go with the original block hash EIP. Vitalik at a certain point suggested a simplified version. It would be nice to just arrive at a decision whether we are doing this, because again, it's in theory it's a relatively simple EIP. In practice, it introduces a new type of account. It's super user stuff. It murks around a bit with gas allowances, because the contract calls get special gas allowances. So anyway, it's not particularly hard, but again, it would be nice to have confirmed that we're going with it before blowing up everything. So yeah, that's about the gas status on the Constantinople fork. As to, I think there was also mentioned previously, whether we want to do Ice Age and Ether issuance stuff. For that, we don't have anything to add, but whatever is decided, we're going to roll with it.
Okay, sounds good. We can try to make some more decisions today, hopefully. Nick and Peter, as far as implementing the the net Store EIP, there was comments last time about the need to maintain a journal for the dirty map and what happens if stuff gets reverted and increasing complexity there. Is that something that we have more information on now, or anything while implementing this that's like something we should know about or would make it easier or harder for people?
So I'll go first, Nick. So essentially, the quick recap: the net storage Astor. So the crux of the EIP is that instead of charging a lot of gas for every operation, we kind of charge a really small amount for every operation, and only charge a big amount if we actually end up modifying the state. Because otherwise, if we just keep overwriting the state with the same thing, then there's no really point, not much point to overwrite it. Now, implementation-wise, this kind of entails two things. One of them is that we need to track the original value. So whenever a new slot is read, we kind of need to put that in some map and keep it around until the transaction finishes executing. And the other one is that we actually need to be able to track whether a slot is dirty or not dirty, because the gas prices change a bit. Whether, for example, if I overwrite a slot with the exact same value, then it shouldn't get dirty. So that's why we kind of need to have dirty tracking. Now, implementation-wise in Geth, it turned out that it's relatively straightforward because we already had the dirty tracking done for optimization reasons, so that we don't update the try only if the value actually changes. So implementation-wise, we only needed to add 3 pieces. One, to track the original values when we first access it. So that's straightforward. We needed a rule so that if we're in Constantinople, then we don't charge based on whether we zero or not zero. Rather, there's more complex logic, but it's actually 4 ifs or a switch. So that was relatively straightforward. And the only addition that we needed to add is that when we finish processing the transaction, then when actually retrieving the refund amount, we also iterate over all the dirty accounts, or all the accounts that we touched, and iterate over all their dirty state items, and just see whether we need, how much we need to charge, or how much we can recover gas-wise due to essentially overwriting with the same thing. So, okay, this was probably a bit not too understandable, but all in all, implementing it in Geth was pretty straightforward. That would be my conclusion. But we did the dirty tracking already. I'm not sure how other clients do it.
I have a question. Do you think there are weird edge cases around stuff like you run a contract, do some S stores, and then you suicide?
I think that's a case where you will potentially be overcharged for gas to the extent where, to the degree where you're currently charged for gas. Personally, I'm okay with leaving a few edge cases like that, because the bulk, it reduces cost to realistic ones for the bulk of operation. Similarly, if you do some S stores and then revert, it still charges you for the S stores even though you reverted.
Yeah, I'm not that concerned about if there's quirky behavior in how the gas is calculated. I'm more worried about quirky behaviors which can cause implementation difficulties and things that we fail to foresee in our testing, and makes life difficult down the road, and they can lead to consensus issues. So
can you elaborate on why self-destruct might interact poorly with S-store here?
maybe if you do post-transaction, you delete the entire account from the storage try, but you also have some dirty mappings which also get deleted, or they don't get deleted, and clients can implement it differently. So I'm just thinking a lot about weird edge cases and potential, how complex it is, kind of.
I mean, the way Peter implemented it after chatting to me, basically all the new state is scoped to a call, just like existing dirty tracking and so on, or existing state tracking. So all of the effects it has should also be scoped to the call that it's in. So I don't think there are going to be edge cases around destroying stuff like that. At least I don't see any obvious association between a self-destruct and how you charge for the gas as the S stores.
Okay, sorry to butt in. You can continue.
No, just to add to that, to Martin's question, I think the two things that, but I wouldn't call them edge cases, but we definitely need to test them, is that yes, when you suicide a contract, then it's a valid question whether the storage slots for those, do they refund gas or don't they refund gas? And all in all, I would say no, but I guess either behavior is valid as long as it is spec'd out. And the other interesting thing that again needs a test is what happens with reverts. So for example, if I modify a storage slot, make it dirty, and then revert, then does that revert the dirtiness too or not? And a more optimal solution would be that it does not revert the dirty. But with Nick, we kind of agreed that, okay, let's revert the dirtiness too, simply because then it is much better scoped, so that we don't have these weird effects that a revertal nonetheless has a side effect. So that's, in my opinion, it's kind of logical, but again, I'm speaking based on our code, so it was easy to implement into our code base. I cannot speak for other clients. So maybe I would suggest that maybe if another client wants to take a stab at it, then they should, and then maybe you can reevaluate it after second implementation.
Yeah, Parity or Ethereum J, do either of you have comments on the potential for implementing the CIP?
And no comments from Harmony. Need just try to implement it. Actually, I don't see any real problems to do that. So, yep.
I haven't looked at it at enough detail yet to have any useful comments.
Okay, no problem. Would it be too much of an ask for Parity and Harmony to implement this to get a better idea by the next meeting? Just how problematic or not problematic this could be?
Yeah, makes sense. But we'll try to do that.
Yep, same here.
Okay, thanks so much, guys. So we can't officially put it on the, roadmap to Constantinople, but I really think it'd be a good idea to put it in. I think it would help, just based on the little knowledge I know about it and how excited Nick got. So I think we should see about putting it in. It's one of the only other ones that we're real close to adding if things aren't too complicated for it.
One suggestion that I could make for Parity and Harmony is that, so I pasted the link to our pull request, and I think the code is really clear as to how it can be injected. And now, obviously, it's Go code, so I don't know how familiar it is or how easy it is for you guys to read it, but maybe it will be a bit of a help to just look at it and see if it's horribly complicated to port this to your code bases or not.
Yeah, no, it's always useful to be able to look at something like a reference.
Yeah, agree.
Where'd you paste that link? Because I don't see it in Core Dev's chat.
It's in the under the PM on the issue.
Ah, got it.
Maybe it's it does make sense to create some kind of a list of implementations of Constantinople to list their or reference implementations like this one.
I can do that in the PM repository where I put the issues for the meetings. I think I tried to do that for a hard fork once and it kind of worked. So I'll use a similar template to kind of track implementations and meta EIPs on who's done with which features. So
yeah, I think that would definitely be useful.
All right, I'll put that on my to-do. So meta list. Okay. So I guess the conclusion is: anyone against trying to implement 1087 net gas metering for S-store operations, and seeing about putting that, basically pending any complications, putting that into Constantinople? Okay, cool. Close enough to rough consensus for me. We should put it in and test it on Parity and Harmony, or not test it, implement it on Parity and Harmony to see how it looks and if there's any things we're missing. Dimitri, last thing, what do you have an opinion on this as far as from a testing perspective? Or do you need to look into it more?
Yeah, well, look at it more. And as I understand, you're talking about revert tests, right?
That's one of the things that was mentioned, yes.
Yeah, those tests were the most trickiest one, and yeah, I might need help with those.
Mhm.
I'm
So
happy to answer
basically,
any
for
questions.
net gas metering, I mean, really, I don't think it will need that many explicit tests because the rest of the thousands of tests that already exist will cover every potential case. That's my guess.
Yeah, so I think just regenerating the already existing test will be fine, right?
I added a list of suggested test cases to the EIP with Peter's help. You could probably have a glance through them and see which of them are already covered by existing tests and if there's anything you haven't thought of.
That sounds helpful. Cool. Any other comments on this, guys?
One comment that I would add regarding dirty tracking. So one thing that, so up until now, dirty tracking in the Go Ethereum Codeways was more like an optimization, so that we kind of tracked whether a storage slot was modified, and if it was modified at the end of the transaction, we updated the storage try, but we didn't care at all about reverts. I mean, we didn't care about unmarking a field dirty. If it was ever written, and even if it was overwritten with the same thing, we just did a storage try update and it was a no op, and who cares? And that's one thing that we actually had to pay attention to, that now we actually correctly track the dirtiness and revert the dirtiness. So that if any client does have optimizations already for dirty tracking, then this is maybe the only case where you actually need to pay attention that the revertals happen correctly. But if anyone who has journaling in place, it should be fairly straightforward to just unjournal a flag.
Okay, that makes sense. Sounds good there. Let's see. And then I guess what we'll do is we kind of jumped around here, but since a few people have to go, I think I've just been told the block hash refactoring EIP 210. Where did we land on that last time? Is that something where we said there were too many? Let me actually just look at the notes real quick.
So Vitalik made a simpler proposal last time, so that leaves us with the old proposal, a new proposal. And on the old proposal, there are a few concerns about the actual EVM code to put there and potential new features to add, like the Genesis.
I see. Okay.
And in both cases, there have been some discussions about how to actually use that thing, because the block hashes will be dynamic and overwritten in time. So I suspect it may be kind of difficult to make a smart contract rely on earlier block hashes, since at a given point you can't really tell what block hashes will be there and which ones will be stored, which ones will be overwritten.
Yes, so just to expand on that, I would say that it would be, before going ahead with EIP 210, it would be nice to have a reason for going ahead with it. Because in the EIP, we have, Vitalik did enumerate a couple of ideas of where that might be useful. But given the nature of how we store and what we store, I'm wondering whether it's truly useful. So in my opinion, it would be nice to kind of iterate a bit on exactly what the purpose of this EIP would be, because I'm not fully certain that it's worth the complexity. Maybe I'm missing something. That's a completely valid possibility. But it would be nice to just have a clear picture of what the purpose is and what it aims to solve.
Do we have other comments about 210?
Vitalik just joined, so he might have some comments.
Oh, wonderful. Okay.
Hello.
Hello. We were just talking about 210, and wanting to get a better idea about the reasoning behind it. That's block hash refactoring, and you recently did another EIP that was like a simpler version of that. Your bandwidth's really bad. You might want to turn off video.
Audio is really bad.
Try it. Talk again. Your audio's still a little weird. Let me see if it fixed it.
1, 2, 3, 4, 5.
Oh yeah, it's still really like staticky and cracky.
Huh. So weird. Hold on, I'll move somewhere else.
Okay, sounds good. Anyways, while he's moving, we got 145, we got 1052, or we got bitwise shifting, ext code hash, we got skinny create 2, and then we tentatively have net gas metering for SStore as 1087. Right now, 210 block hash refactoring, we're still trying to decide the purpose of it, kind of rekindling that.
Well, at this point, I would probably favor WT over 210. Basically, the reasoning is that that is used to have an EVM contract at the protocol level. But if we're not going to have EVM contracts built at the protocol level, and instead we're going to move toward WASM contracts being built at the protocol level, then if we want to get the benefits of it, it probably makes sense to just extend it in a way that's like written in native code and much simpler, which is what 1218 does.
And 1218 is your newer one, right?
Yes, it's called a simpler alternative to block hash extension 210.
Martin, did you have a question or a comment?
Yeah, so I was just curious about Vitalik's take on the fact that we overwrite block hashes and block numbers, and that the contract at a given point can't really be certain which numbers will still be available. So in a real practical use case, it might be difficult to use this information.
So the overwriting is kind of necessary because otherwise this whole thing would have O of n storage overhead. If we want to, like, basically the idea is that if you want a use case that has like some larger range of durability, then you would basically use a block hash that has or use a block number that has a larger number of zeros in its binary representation, and that way you have a larger span of time within which you can submit the block hash.
Right, and that means you might have to wait like a year from Constantinople. You might have to wait a year until the block you're certain will be there a year from that, something like that.
Yes, although that's okay. So if you want like certainty that you'll be able to use the same block hash for a year, then you'll have to wait a year. If you have one application, then one thing that you could do is you could just have a feature that calls the contract once and then just like basically stores that particular block hash separately.
Hello, we can hear you. I was just waiting if Martin had a response.
No, I don't really, because I find it a bit difficult. I feel like Peter said that it would be nice to see examples of use cases, how use to see the benefit of it.
I can definitely add examples.
Yeah, if you could add some of those to the EIP, I think that would help the discussion.
Okay, I'll do that.
Wonderful. And if you can mute when you're not... Oh, great. If you can mute when you're not talking, Vitalik, that'd be great. I just saw you did. Okay, so we'll talk about EIP 210 more next meeting. Right now, there's... Or not 210. We'll talk about the new number, 1218 or whatever. And we will follow up on that. Let's see. But right now it looks like it's not going in until we have more information and stuff like that. I think that's actually all the Constantinople EIPs we've talked about. A lot of them are implemented. I'll make that meta chart that I talked about that shows which clients have implemented which EIPs. In doing that, I was going to add all of the like Geth, Parity, Harmony. I was wanting to add Pantheon, but is Pantheon still closed source?
Hey, Hudson, Matt from Pegasus here. It seems like it's probably going to be closed source up until our expected release date at DevCon 4.
Got it. Okay, no problem. So let's go ahead and go to back to client updates, and then we'll do research updates after that. So Harmony.
Last 2 weeks we worked mostly on sharding research. Hence, there is no major changes in Ethereum G or Harmony. And we plan to start to work on Constantinople in the next 2 weeks. So, yeah, and about sharding research, I guess better to say it in the research section.
Great. Trinity.
Yep. So we published our second kind of major named release this week, and while we're still waiting for the client to finish, we think we have a client that fully syncs with the mainnet right now. So another day or so of state syncing, and then we think we'll be there. So lots of improvements on performance and syncing reliability. Yeah, things are coming along quickly and really nicely. We have not started on any Constantinople EAPs, but we have issues open for all of them, and we'll probably start biting into them very soon.
Okay, thank you. CPP Ethereum.
I think Pavel is about to release the new version.
So in terms of Constantinople hard fork, we have bitwise shifting implemented and create 2, and external code hash is in progress. So I have a tiny comment about Xcode hash, but it's more about EIP itself. So I'm sure there's good time to talk about that.
No, you can talk about it right now. That'd be fine.
So one detail there is in the current spec, you can the empty accounts are distinguished from not existing accounts because the empty account will have a non-zero hash of empty string as a result, and non-existing account will just output null hash for this opcode. I'm just trying to collect information if developers are aware of this and if that's a good idea.
Well, that's kind of works the same way that
Oh, Paul, can you mute when you're not talking?
One moment, let me look it up.
Oh, Peter, did you say you were looking it up, or did you put yourself on mute accidentally?
No, keep discussing it. I'll try to look up a reasoning.
Oh, okay, no problem. And that was for which one again? EXT code hash, right?
Yes.
Who authored that? Was that Nick and Powell?
It was Nick. I made some improvements to the spec.
Oh, okay. Sounds
so
good.
This is kind of new information available to contracts because it was not directly exposed. The only thing the contract could see before is different call cost in case the account existed or not. And this allows actually like more direct access to this information if a contract would like to check whenever the account is empty or doesn't exist at all. I mean, it's yeah, mostly you can check if the account exists. However, I'm not sure like the definition of existing account is very precise within the all Ethereum specification.
Any comments on that? And Peter, we can come back to this in a little bit if you're still looking.
No, I didn't. I misremembered something. I was just checking how we implemented it because I know that we had a back and forth on exactly the differences between empty accounts, non-existing accounts, empty precompiles, etc. But yeah, we just if it if the account doesn't exist, we just return 0, and if it did exist, we return the empty code hash. And for precompiles, we return the empty code hash since they do exist.
Okay. Any other comments on this?
Yeah, a comment. Peter, when you say for precompiles we return the empty code hash, that's only if they exist, right? Which is not a given. I mean, it happens to be so on mainnet right now, but.
Oh yeah, exactly. So this is actually a very good corner case, Martin, that you brought up. That our implementation currently just does yes, if the account exists but there's no code in it, then we return the empty code hash. That for precompiles too. However, if the precompile does not exist because it doesn't have balance, then we return 0. So this. In my opinion, this is a good behavior because otherwise, all of a sudden, this opcode will need to be aware of whether something is a precompile or not. So I think this approach is better, but indeed, it's an interesting corner case.
Okay. Let's move on to the other clients.
Actually, one quick question.
Sure.
We had that weirdo special case in the yellow paper regarding the RIPE-MD 160 precompile. In the end, did we delete it or didn't we delete it? So I know that was the time when both Parity and Geth implemented different things wrong. And then in the end, we went with Parity's, so to say, bug because it was easier to reproduce the bug than to fix everything. But I don't remember. I know that it was something after the cleanups, the Shanghai attack cleanups.
So I think in the end, we are following an inconsistent rule in this case.
Yes, I know, but the question is, did we actually delete that RIPE-MD contract or didn't we delete it? Because if we didn't delete it, then we don't really care about this specific corner case for mainnet. If we did delete it, then we need explicit tests for it.
I think we did delete it, and after it, we just recreated it with sending some balance there manually.
Okay, yeah, that's fine.
But these cases for precompiled are listed in the list of test cases in the spec.
So this is actually, as someone implementing a client and coming online to mainnet, I actually had some questions about. So you can find out about this transaction at block 2.67 million in the yellow paper, but in terms of the actual behavior being locked into an EAP or somewhere else, look at a specification, it doesn't seem like it's ever really been finalized. And so I was wondering if for Constantinople, maybe we could get some closure on that. I also think if you look at the client implementations, there could be cases where they could also handle other edge cases differently. So it could probably be something good to get that closure on.
So me and Yuichi spent quite a lot of time trying to find some common ground on how CPP, Geth, and Parity handled this special case that happened around 2.6 million somewhere. And there's an open ticket for that. And it's really, really a mess. So I can send some links to where that is. And we can take the discussion offline because it's quite a long discussion actually.
That would be great. Thank you.
Cool. Yeah, I remember there was actually, and you probably still have this, Martin, there was a long document that either Yoichi or you and Yoichi created. It was just a gist, but it had like the whole story and like what ended up happening and why the yellow paper is written as it is. So that'd be helpful, I think.
Yeah,
Um,
I'll find it.
Wonderful. Next we have, okay, so we went through Harmony, Trinity. Is there Nimbus, Mana, Extherium, or any other clients I'm missing? Pantheon? Oh, Pantheon. You're here. Okay, because we talked earlier. What's the update from you guys?
Yeah, don't forget about us. So Pantheon's at the point where we can connect to mainnet in a stable way. So Discovery Layer seems to be working pretty well. Same with RLPX, and we're at the point where we're able to perform full syncs. It's not optimized at this point, but we're well into block, or we're well past block like 2.48 million. So right in that transaction attack chain segment. So we're letting it run. We're seeing how far we can get. Beyond that, we still have a few pre-compiles to do for Byzantium, and we have not started thinking about Constantinople yet.
Okay, thanks for the update. Any other clients I'm missing? Okay. There's a brand new client that I haven't been able to reach out to, but I'm going to post the link to it. It's called Nethermind. It's a full .NET Ethereum client. So unlike Nethereum, which is a .NET integration library, this is actually a full client. So I'm going to invite them to the meetings if I can get a hold of them. Does anyone know the person who does this? Okay, yeah. I hadn't seen him around either.
Yeah, their GitHub activity seems to have dropped off for the past month, so I'm not sure where they're at either.
Mm-hmm. Okay. So, just a second. Let me do something real quick. Okay. I think I'm still here. My Zoom client freaked out for a second. Ewasm, do we have an update from Axic?
Sorry, I was just trying to find the mic. We don't have any substantial update. The testing and especially testing of the pre-compiled implementations is ongoing, and we are closing off a couple of, or at least discussing a couple of design issues in depth. That would be most of the update.
Wonderful. Okay. I think if there's no other clients, we're on to research now. So that would be Vitalik and Danny. Whoever wants to do an update.
I can give the details and Vitalik can fill things in. The Casper sharding version 2.1, there's kind of a working spec that is getting close to complete. The spec combines cross-links and attestations for a cleaner design, and introduces a new fork choice rule, recursive proximity justification, which is still pending a little bit more peer review. Vitalik posted proposed epicless Casper on ETH Research recently, and the intention is to introduce this design, but it's still pending some more peer review at this point. We're doing a sharding implementers call, the first one on Thursday, so a week from yesterday. We talk about that on the sharding getter if anyone's interested. Please come. VDFs are being proposed to be using in the sharding RNG adjustments. Some of the security parameters depend upon how much an attacker can, how much advantage an attacker can gain by like producing sophisticated hardware to do this. So Justin's getting some real world info on with a hardware manufacturer on some of that. So I think that's mostly what's going on. Vitalik, do you have any other notes?
Yeah, I think so. Like the two key things that I'm working on from my side, one are that epoch-less Casper, and which basically is an improvement on Casper that allows any epoch to be justified and finalized, and so takes the time to finality down to like basically equaling the optimum. So whereas below it was like 25% above optimal, and it also like basically simplifies the algorithm because we don't have to separately worry about like what happens inside an epoch versus what happens across epochs. And then the second thing is recursive proximity to justification, which is the fancy name for the fork choice rule, which once again now only needs to have basically one component instead of two. Let's see. So I did a quick implementation of a quick version of recursive proximity to justification, which is kind of in the category of ghost algorithms, and it seems to work very well. Though it does, and it manages to like justify and finalize things even with extremely high network latency. Though I think the next step at this point is to try to take both that and epoch-less Casper and formally prove some properties about it and nail down more details of the protocol. And at that point, like the main reason behind this work is basically it's a separate line of research from Justin's VDF work, where the purpose of this is to make the algorithm highly resistant against even the VDF failing horribly. So basically, the algorithm is robust against the long sequences of bad proposers. And it's and so far it seems like it does the job, but like once again, we do need like more to kind of spend more cycles like working out the details and ideally getting some kind of formal proof of it out for various different properties.
Okay, cool. Thanks for the update. There was also Ethereum JS, which I skipped because Holger's not here, but he did put a comment that said they just did their first release series version 2.4.x, where they have partial Constantinople support and some other cool things. They're going to write up issues for Constantinople EIPs soon, and they have a Reddit follow-up call for participation. Because they don't have enough people to implement it all themselves. So if y'all know any good JavaScript developers who are interested in building on a client implementation of Ethereum, send them Holger's way or send them my way, and I'll direct them to the right place. Same thing with testers. We could use some more testers. All right, next was supposed to be the difficulty bomb diffusal or the reduced block reward, but I actually want to skip to potentially lowering the cost of precompiles because that'll be a quick one, and I don't want to leave that out. So Martin, do you want to take that?
Sorry. Yeah, sure. So there's been some suggestions about lowering the costs for the new modern precompiles. I've done some benchmarking of that. You can see the results. And as it is right now, there is some, yes, we could lower the costs of, let's see, easy add and easy mull, though not drastically. We can't really lower the cost of MODEX, and we can definitely not lower the cost of pairing as it stands right now. Geth would make it, but Parity would have some serious problems with that. On the upside, Parity has looked into the feasibility of improving that. I don't know, do you guys want to talk about it?
Yeah. So Andre's been working on it for about a week, and we have a PR in now that doubles the performance. So it's a 2x speed up, but not really close to the 10x that we'd need. And the problem here is sort of Geth relies on this Cloudflare library that has super specialized assembly for 64-bit architecture, so on BN 128 and 256. And it's not really something that we can, like, we've dug in to try to see if we can use that somehow or integrate it or like what our options are, but it's very, very involved. This implementation, actually, we noticed this when going through it. says that it's for non-commercial use only, yeah, so we couldn't really copy paste that either. So basically, we're at a point where we can get 2x relative, like that. We have a PR in for that. We can maybe improve it in some ways further, but to get the 10x we'd need, it needs like a low level expertise that we really don't have right now.
And are you talking about the pairing right now, or
Yeah.
all of them?
Yeah, the pairing specifically. We have a PRN to improve ModExp and some other stuff as well, but the pairing specifically is the hard bit.
So basically,
if someone could port the Cloudflare library to Rust, then we'd be good to go. But it's harder than it sounds.
So according to the charts, we could basically do a halving of the cost for add and multiplication, roughly, and not really do anything with ModEx. Well, maybe halve it if Parity are able to improve it. I don't think we can do anything with pairing at all, even if they double the performance. So that's where it is right now.
This is Piper with Trinity. I'm kind of coming into this without a lot of homework being done, but I know that our implementations of those are extremely slow. They're implementations that are done in pure Python, and as far as I remember, when I was implementing those precompiles, there were no other options that I could find available. So, and I don't really know what other language ecosystems are looking like as well, but I'd be wary of dropping those gas costs for the current implementations and thus making DDoS vectors for any new clients that are coming online that don't have access to a fast version of that.
So I'm not per se the proponent of lowering gas costs. I just made a feasibility study. But if anyone here is champion of that, yeah, please go ahead and talk about it.
Yeah, I don't know if it has a champion right now. And that's for an EIP lowering gas cost, right, Martin?
Yes, for these particular ones, ModExp, ECID, small and pairing.
I thought Vitalik wrote something, or was that for a different set of?
Yeah, no, I did write. I did write an EIP for reducing gas costs.
You know where that is?
Not sure about the number. It's like in there somewhere, but it's very like small and simple.
Okay.
I think someone posted the numbers today on the PM comment section.
Oh, okay. Yeah, let me look.
Yeah, Barry White had posted. So it's E1187 and 1108.
1187. Where is that posted? I'll just go to it. Yeah, gas cost reduction for ECID, ECMOL, and ECParry is 1187. So I'll copy that in. And then, what was the other number, Martin?
1108.
Okay. Oh, that was actually 1108 was merged. That was Nick's. Nick, was this actually implemented? Oh, it was merged as draft, wasn't it?
Which is this?
1108. I just posted it in the core dev chat. It's to reduce Alt BN 128 gas cost.
Yes, I think it's just a draft. I mean, our policy is now to merge drafts extremely quickly. So.
Great. And you're still in favor of this EIP going forward?
I have no opinion on it. I only merged it because it met the type of requirement.
Ah. Oh, yeah, who was originally... Oh, this was... Oh, okay, sorry, I read that wrong. I thought you wrote it. I haven't had coffee or anything today. Okay, that was a different person. So it looks like there kind of are champions for this, Martin. It's just, they might not be as loud. So yeah, any other comments on this? I think reducing gas cost is something everyone can kind of agree on, right? Or is there not a reason to do it?
Yeah, well, the feasibility study says basically that it really can't be done as it is. We can't reduce pairing at all, and we can't reduce easy mode by a factor of 4 is a bit much.
Okay. Sounds good. Any other comments on this?
One suggestion I've seen raised elsewhere is the idea of reducing the general core cost for precompilers. It's currently 9,000, same as general account.
You go closer to the mic.
Sorry. One suggestion I've heard is that of reducing the generalized core cost for precompiles, which is currently 9,000, the same as general contracts.
What do you mean 9,000?
The standard cost to execute a call operation.
Is it 700?
Sorry, I think you're right. For cheap precompiles, though, it still adds up to a significant fraction of the cost. Yes, you're right, at 700. For instance, the identity precompiler was previously used as a mem copy, but it's no longer cost effective to do so.
Yeah, so that would affect basically the add and the mul, but the pairing, I mean, it's 900,000 at least. So it doesn't really matter for that one.
For the pairing stuff, if somehow we do get the 10x improvement, what's the possibility there?
Yeah, so if you get it, so Geth would be able to, what today costs 900,000 gas. Geth would could cut that down by a factor of 4 safely to about 250 220,000. And would be in the same area if they went down by a factor of 10.
Yeah, I mean, then like it's theoretically possible for us to do that. So it's just a matter of getting the right person to be able to do it. But then the question is really just like, do we want to depend on having these hyper optimized assembly implementations of pairings available for all clients?
Yeah, and it doesn't sound like it's feasible for Constantinople to mess with the pairing.
I mean, maybe, but I wouldn't commit to it right now.
From what I'm hearing about how much from what I know about how much these cost to run in Python, like this is potentially already close to a DDoS vector for us. So dropping gas costs is gonna be it's gonna impact us a lot. Us being Trinity in the Python community.
Similar for Pantheon as well. It's something we don't know how it's going to perform yet either.
Yeah, so I would propose that we don't change the cost this time around.
So I think it's a bit this issue will happen again when we going to like depend on different cryptography. And I think it was discussed in some conference recently about PLS signatures and so on, that there's one library. And I think we have one example when we used all of the clients use the same implementation, and it's SecP256K1 when we just use the code from Bitcoin. And maybe that would be some approach we should try to get. So coordinate effort to have maybe single good performing implementation that would be available to, let's say, new clients and new teams that want to focus on different aspects of the software than optimizing the same problem all over again.
Yeah, from a security perspective, though, the one issue is now you have language bindings, which have been attack vectors in some cases before. So, you have a very secure library, but then the interfaces may not be as secure.
Yeah, but we are using that already, so. Having different implementation of the same cryptography, I don't think it's better, because you can make mistakes differently. But I'm not security expert, so yeah, I'm open for comments in this case. But happened that we use the single library in every software for Ethereum clients.
I have a question for Vitalik or whoever is champion.
Yes.
This. Would it make, if we do a halving of easy add and easy mul, but nothing else, would that enable anything? Would that be worth it, or is it just too little?
It could be. Like a halving for ECMol, it would definitely make ring signature stuff considerably more viable. And I guess for EC add, the benefit is that it would make like BLS aggregate signatures more viable.
Mikhail, did you have a comment?
Yeah, I have a small comment that as for Java, we can try to create a GNI for this Cloudflare library, but it's definitely will take a while. So yeah, need to look at this library.
So the problem with this library, or not problem, but like what makes it hard for us is it has a fairly tight integration with Go, and Go is big in its library. And so it like breaking out the assembly parts is not as easy as just like taking those and copy pasting them somewhere else.
But it's possible to compile this library in just a binary, right? I guess. So, yep, we can just use binaries, like wrap them. I mean, in terms of Java, GNI bridge.
So I don't think it's easy in this case, because Go has its own runtime. You'll have to include with this library, I think.
Yeah, I'm not really sure how that would work either. I think you'd run into that. And then there's like the issue of the thing that I mentioned, that this library is not actually allowed to be used for commercial usage. So, and that's something that we apparently want to still keep. So we couldn't use the library directly.
Okay, that was just a thought about that.
Yeah, still for Java, the better solution would be to have something that is doesn't have garbage collector inside. So any C, C++, Rust, and it would be much convenient to include that in any other languages, I guess.
Yeah, maybe. Never try to work with Go binaries from Java.
Yeah, we've been using Bouncy Castle in the Pantheon code base, which is Java based.
Yeah, we use it too. Actually, we use Sponge Castle with it, which is a copy of Bouncy Castle with some changes for Android. As for pairing and multiplication and addition for those curves, we just use our own implementation, which was ported from libsnark library. So it's not super efficient, I guess.
Okay. Do we have other comments on this?
I think I was just going to generally say that, we want to encourage a variety of clients to operate on the network, and we start providing gas costs that bias specific implementations. We might be raising the barrier for some of those implementations. That's the way I'll.
Yeah, it's good to have something more even across the board, I guess, for different implementations. Any other comments? So Martin, did you get what you needed to out of this discussion? Is this something we should bring up next meeting? What are your thoughts?
No, I just wanted to give some feedback to whoever wants to pursue this and wants this to happen, so that they can change the ETH and make something a new proposal. Maybe I don't really have any skin in this game.
Okay, so it sounds like the only real person who's championing this right now that we're aware of is Vitalik, and I don't even know, Vitalik, how much do you even want this in?
I don't care extremely.
Okay. For now, we'll leave it out then. Thanks for running those benchmarks, though, Martin. That helps a lot.
You're welcome.
Okay. So the next item on the list, which actually goes back up to 4, is there's 4 EIPs to either delay or completely remove the difficulty bomb and or reduce the block reward. So there's 858, 1227, 1234, and 1240 that's on the agenda if you all want to kind of look at the reasoning behind some of these. But I think what I'm going to do is just get general opinions on this, because we're not going to be able to decide this part today, likely. First of all, can anyone give a concise reason to, or does anyone want to remove the difficulty bomb entirely? I've never heard anybody speak up about that, and the person who's proposing that is Micah Zoltu, who's doing it for what I would consider philosophical reasons behind what miner incentive is. So does anyone want to remove the difficulty bomb completely? Cool. And yeah, go ahead, Dimitri.
I don't think that the difficulty bomb was a good idea in the first place.
Why is that?
Initially, it was implemented to switch into proof of stake, right? And we are not there yet, and we just keep moving the difficulty bomb, and it's additional tests about difficulty being calculated in a weird way. It's not good.
So I want a question that I hope someone can answer. What is the purpose of the difficulty bomb today versus when it was actually first implemented? Because my impression is that it forces miners to participate in hard fork updates. Is that not what it is today?
I'll speak up from my own personal point of view, which is that the difficulty bomb makes inaction not an option. That if nothing else, we have to do something every some amount of period so that inaction isn't the default course of action.
Agreed. And the corollary of that is that it removes or lessens the sort of default effect of inaction being the most attractive option.
Okay. Anybody else have comments about what the difficulty bomb means for us today?
I agree with the previous speakers.
And to add to that, that is that I support that. I think that that is a very good feature for us to have, to require some sort of network action every, some period.
Just a related question. As you said, Hudson and Dimitri, I think when it was first introduced, it was sort of specifically around proof of stake. But what Piper's alluding to here, what I think we're kind of alluding to, is that it's more just, it's not for any particular move or switch. It's just around participating in hard forks and removing the default option. And so is it just a general thing? Is that kind of what we're saying right now?
That's what it sounds like.
Yes, correct. My intent is that it isn't really necessarily applicable to miners or anybody in specific. It's just that in general, the royal we, everybody must do something to keep the network up and running every, some amount of time.
And I guess the follow-on I have then is, if it were specific about transitioning to proof of stake, then we might agree that it would be removed after that transition is complete. But are we suggesting we want to keep this forever?
Without having done a lot of deep thought on it, yes, that is my personal opinion.
I feel so. I feel like after proof of stake / sharding, it probably would make sense to have it exist on like much longer timescales, because I expect that like the rate at which the blockchain will change would not need to be as large as it was before. Though I'm not sure if I kind of have a strong opinion about whether or not it's something that should be kept forever or not.
Okay, so it sounds like we pretty much have consensus that we don't want to remove it entirely. As far as delaying it, I think everyone we kind of agreed last time we need to delay it. We need to delay the difficulty bomb, otherwise block times are going to get really high starting in 2019. Is that correct?
Yes.
Okay. So now we get to the point where there's some EIPs that do a combination of delaying the bomb and changing the difficulty reward. I was going to wait for the end to kind of suggest this, but I think we should separate the two. I think traditionally we've had it in the same EIP, but I think decoupling them would help us create priorities where we have one thing that's a economic and technical change and the other one's a pure technical change. That doesn't have to do with as controversial of a thing. So as far as reducing the reward, there's people who say that it should be reduced or increased. Some people say it should be reduced to 1 ETH. Some people says it should be changed to 2 ETH, and others said it should be changed to 5 ETH. I can go back between ETH and ETH. Is it 3? Is it 3 right now? Is the reward?
Yes, it's 3.
Okay. What are the reasons to change the reward at all? Because we've done it before.
The theory, I guess the main one is just that like the chain is overpaying for security.
Interesting. Okay. So let me just open up a couple of these and see if I can get some keywords or key phrases as to why.
Oh, I need to head off in a couple of minutes, by the way.
Okay, no problem.
I think we can also make the general statement that if we do delay the difficulty bomb and do not change the block reward, then overall inflation over time increases. And so there's sort of this, I guess, maybe philosophical, maybe economic question about which is the intended issuance schedule. Is it kind of the issuance schedule that exists with the bomb or without it?
Mm-hmm.
So can you repeat that again, Lane? I don't think I followed that.
Sure, I'll repeat it, and then if Vitalik or someone else wants to expand on it, please do.
Oh, you cut off, Lane. Can you hear us? Hello, Lane. Oh, okay. He's been muted and unmuted.
I think what he was implying is on a chain that has the difficulty bomb, issuance actually goes towards zero. And so changing the block reward to 2 or to smaller, while at the same time delaying the difficulty bomb actually increases issuance, or like stabilizes issuance, which is different than what would happen if you did nothing. I don't know if I necessarily agree with that, but I think that was his intention.
Hey, Lane, are you back?
Sorry, Hudson, can you hear me now?
Yeah, I can hear you now. Go ahead.
I got a phone call, and for some reason my audio cut out. Sorry about that. I'll repeat what I said, and if someone else wants to clarify, please do. I was just saying that if we were to make the decision, hypothetically, to postpone the difficulty bomb, but not to change the block rewards, then if you kind of look at overall Ether issuance over all time going forward, it goes up as a result because the block times come down. Does that make sense?
I see, yes. But that would be because that's purely because we have the difficulty bomb. Otherwise we would not need to do that, right?
Right. But so then this leads to this very interesting sort of economic / philosophical question, which is like, what is the quote unquote intended issuance schedule, that the market is factoring in, so to speak? Is it the issuance schedule with or without the difficulty bomb? And this goes back to the question I asked before, which is like, do we intend to keep it forever or not? So it's all kind of tangled up. But I would be very curious to hear what Vitalik and others have to say about that.
Yeah, who has strong opinions? Or any opinion. Yeah, Vitalik had to cut out, so he's gone.
I think that's a nice argument for the reduction. I don't know if it's completely, I don't know if that's the original intent of the difficulty bomb, but the original intent of the difficulty bomb was to move to proof of stake, which would ultimately greatly reduce issuance. So if you want to piggyback on that, this is kind of in the spirit of the original difficulty bomb because it's a reduction, but it's not the move to proof of stake. So, it is very tangled. I think that with EIP 1011, I put out kind of an analysis of the Ethereum mining reward and how, if you look at it in comparison to some of the other blockchains, especially even like Bitcoin Cash, that we are overpaying, and that a reduction, we'd still be an extremely competitive proof of work blockchain. But some of that analysis was, one, it was to move to 1 Ether, and it was also with the assumption that we gained security with the overlay of proof of stake. So some of the analysis, I'll post the link of the original stuff. But I think that, as some people pointed out, reducing block reward without at least considering ASICs, which I think have, at least I saw a video of one the other day. I think they do exist. I think that the conversation, they need to be talked about at the same time. I think at least a lot of people in the community want them to be talked about at the same time. The fear would be if there are a lot of ASICs in the network and you do reduce the block reward, then that would reduce kind of the consumer miners and potentially just have more and more ASICs on the network. I don't know how much validity there is to that, because I don't know how many ASICs are out there and what the exact specs are, but it's something to consider.
Interesting. Okay.
Just one thing to add, Hudson. You had suggested decoupling these two, and I think you said on the grounds that one is sort of purely technical, meaning postponing the bomb, and the other is economic and technical. I guess what I'm suggesting is that they're actually both economic and technical, and I'm not personally convinced that it should be decoupled, but obviously open to what others have to say about that.
Yeah, I'm good with them staying together if it makes sense. So I don't have a super strong opinion on that. It's sounding more and more like they do go together, actually.
I would agree.
Yeah. So Ofri, I know you did 1, 2, 3, 4. Do you want to kind of discuss your reasoning behind it and what you're championing there?
Yeah, sure. I just stepped up to write this proposal. I templated it based on 649, which we used for the Byzantium fork. It's basically the same mechanics, delaying it by 3 million blocks and decreasing block reward by roughly 30%, 35%. And I have actually a strong opinion on not separating block reward from difficulty bomb delay, because delaying the difficulty bomb, like Lane's already said, that has an economic impact, and reducing the block reward tries to counter this a little bit. And the danger of separating both of them is that in case we decide only to do one of these two things, this means we significantly change the issuance model of Ethereum, the inflation model. And that's why I think they have to be in one proposal. This does not mean I'm super convinced that the numbers I've chosen for this proposal are the best numbers. I'm up for suggestions, but I guess it's a good start to discuss it.
Do other people have comments?
I have one. Just stepping into the sentiment and especially what Piper mentioned, that it is a force that we do something every certain amount of time. And especially, I don't know the number, but the proposal from Afri says that the timelines are shifted out to like mid 2020. And I wonder if there's any sentiment to if any changes made, it should only give us time for 12 months. So there's at least one change every 12 months. So practically a hard fork every 12 months. Or is there any such time we should agree on?
Yeah, we definitely need to agree on a timeline. I think usually we just kind of pick a time, and I don't remember, at least the last time we discussed this, I don't remember there being that much discussion over it, so we should have more this time about how much of a timeline we should have. So
There was a discussion at DevCon last year, and I think we were tossing around numbers between 9 months and 18 months, with 9 months feeling way too short, and 18 months sometimes feeling long. So 1 year is something that I at least could get behind, but I agree there should be discussion because this affects everybody.
And we're currently discussing releasing a fork about 1 year from the previous, just for one data point.
yeah, that's true, actually. Yeah, it would be about a year. Interesting. I think having them once a year is probably an okay thing. Even if especially if we decide to have two in a year or something, that could also be a positive. That seems a little short, though, actually. Yeah, having them once a year is not a bad deal.
I think we have two unrelated discussions here right now, because we don't want to delay the difficulty bomb twice per year, I guess, or once per year. I'd say we want to just delay it or disable or whatever we decide in future whenever necessary, but not certainly with every fork. So it might be a good thing, a good practice to say, okay, this delays the bomb by another 18 months, for instance. So we have like a buffer of time in case we have a longer schedule to do hard forks or something other delays.
I think that was also part of the discussion, which was basically always, even if we do a fork every year, always pushing the difficulty bomb out like 18 months.
I see. Okay.
Yeah, I think that makes sense.
That makes sense to me too. Okay, so we're kind of we're talking about 12 to 18 months being the times that we're deciding on for delaying the difficulty bomb when we delay it. And then as far as reduction of or increasing the reward, we will need to talk about that more. We have to wrap up in the next minute. But if y'all could go in and kind of comment and look at some of the EIPs about block reward reduction and block reward increasing, and just kind of try to come to your own opinion so we can have more opinions the next meeting, that'd be great. We also don't have anyone in here for the Fellowship of Ethereum Magicians update, except maybe Offrey, but we might want to save that up for next time if we can have Jamie or Greg or someone come to the meeting and talk about it, because I think there were some things that were very relevant to the core devs call, even though generally I wouldn't like something like the Fellowship of Ethereum Magicians updates to be in the core dev meeting. I think that this gathering they recently had is important enough to have them explain some things they talked about and have the all core devs chime in on the direction of the EIP process in the future, especially when it comes to EIP 1.
Thanks for sharing that. I agree. We should discuss this more on the next call. One super quick thing that's just maybe worth mentioning is that the Fellowship of Ethereum Magicians is planning another gathering, I believe, in Prague. It's looking like just before DevCon, and so there's definitely some interest in including, the All Core Devs audience in that, if possible.
Cool. That's something I'll try to make. That'll be fun. All right. Thanks, everybody.
Before DevCon, but after Web3 Summit? That's the 1 week in between.
Yeah.
All right, cool.
All right, awesome. All right, thanks, everybody. We'll see you in 2 weeks. Goodbye.
Thank you very much. Goodbye.
Bye.